Okay, so the deal is, remember this situation? This is essentially what we're doing for our lab today, where this little guy right here is the only force that is causing this whole system to move. The gravity pulling this one down is resulting in all of these sliding off the table. So the force being just the little blue block, and then the system accelerating being the little blue block and the mass of the red block. Our situation is going to be like this today, except this will be the mass of the cart, and this will be the mass of the hanger. Likewise, the only thing pulling the whole cart off the table is the little weight of the hanger. What we want to see is, well, these should be equal to each other. We're going to calculate this side by taking the m times gravity of the little hanging weight, but then we're also going to measure this side. We're going to measure the masses, add them together, and we're going to measure the acceleration. We're going to see if this really does equal this. This is the cart. This is the pulley, which the string hangs over. This is the weight, which hangs at the end of the string. And then this is the motion detector. It works a lot like a bat's echolocation. These are the different weights that you add to the cart as you do the different colored trials.
So this is the Vernier Dynamate, and this wire here, it's got a USB cable on the other end, it goes into the computer. This one here, it's got a little Digisonic cable on the other end, it looks just like the first end, it goes into the motion detector. And this guy here, people forget the most often, it is the power outlet, and it goes into the wall, or the power plug, and it goes into the wall.
The way the motion detector works is it sends sound down the track, and some of it gets bounced back. However, sometimes it hits the wrong thing and bounces back, and it gets a bad reading. So don't stand in the way.
Oh my mother.
So here's an example of what some data may look like after running one trial. What you're going to do is highlight the area where the cart was accelerating consistently, and then hit the stat button up here. It's going to bring up a dialog box that tells you statistics about the data that you selected.
So then what you're going to do...
The average height of the graph for that area would be the average, or the mean. You'll notice that when you type in your data, it rounds to the nearest significant figure, which is good.
And you'll notice that it rounds for us. When you go to record your second run, do not reuse the box. Get rid of that box and start a new one, making sure that this time you do not include any of the bump data or any of the data where the cart was not accelerating consistently. And the second one was 0.3666. Okay, you'll notice how it rounds.
This is the weight of the cart plus the weight of the hanger, and then the rope doesn't matter.
Mass times gravity of the little weight. So we already said the little mass was 0.02 kilograms times 9.8. Mass times gravity. Mass times gravity.